Students, today we'll be learning about electroslag welding. Electroslag welding. This welding process is generally used to join very thick work pieces. The thickness of work piece is quite high in this process. So let us see the setup of this process. In this process, the thick work pieces which are to be joined, they are kept in vertical plane and they are kept over a starting piece or a base plate, and on both the sides of the work pieces which are to be joined, the copper shoes, these are water cooled copper shoes which are kept. Here in this figure, the sectional view of the water cooled copper shoe is shown. One is on the left side of the two work pieces and another is on right side of the work pieces, right? That is rear shoe. And these copper shoes which are water cooled, they are kept in the beginning of the operation at the bottom, and they form a cavity. These two water cooled copper shoes form a rectangular cavity within the work pieces which are to be joined. Now in this process, in the beginning, you can see here the bare wire electrode is shown, and here it is flux hopper. So initially the arc is established between the base plate or the workpiece and wire electrode to start the operation, and the granular flux is filled in the cavity. Now because of the arc which is established between the bare wire electrode and the workpiece, the metal or base metal and filler metal melts and makes a layer in the cavity, and this molten metal, when it reacts with the molten flux which is present there in the cavity, forms slag by reacting with the impurities present in the molten metal. When a layer of slag is produced over the molten metal layer, the arc is quenched, and this molten slag, because of its resistance which is offered in the flow of electric current, it becomes heated, and a temperature of the order of 1700 to 1900 degrees centigrade is obtained in the molten slag which is floating over the molten metal, and because of that the incoming bare wire electrode is melted, and at the same time the base metal is also melted because of that temperature. Now as this bare metal electrode is automatically fed at a constant rate into the cavity, and at frequent intervals the flux is poured in the cavity so that necessary slag can be produced or impurities from the molten metal can be removed. Now as the molten metal is in the cavity is filled, and because of the water flow in this water cooled copper shoes, the metal gets solidified, and as the metal gets solidified, these copper shoes are made to move upward in a programmed manner, and Further, metal from the wire or bare wire electrode and the base metal melts, slag is produced, and the process continues. So this process is generally also a type of progressive process of melting and solidification. See here, initially the workpiece and the base metal and the electrode material was in molten state. It became solidified. Now here, in this time, the metal will be in molten state, and when this cavity will be filled, the shoes will be moved up, and here the metal will be solidified, and on the top of the here metal will be in molten state. So this is a progressive process of melting and solidification. So in this process, the two phenomena of in the starting, heat is obtained from the electrical arc to start the process or to initiate the process, but in the process later on, and for entire welding process, the heat is obtained from the resistance of flow of current through the molten slag, and because of that, a sufficient temperature, that is of the order of 1700 to 1900 degrees centigrade, is produced, and because of that, filler metal, that is electrode metal, and the base metal melts because of that temperature. Now this process generally is used to join very thick work pieces. In this process, residual stresses and distortion developed are quite low, and metal deposition rates are quite high, and during the process there is no much complication in joint preparation. This process is generally used in shipbuilding industry and for welding nuclear reactor vessels. To summarize again, this process is initiated by initiating an arc, electric arc, between the tip of the electrode and workpiece or starting plate, and later on the heat is obtained for the fusion welding by the resistance of flow to the current in the molten slag or through the molten slag. So this was all about resistance, or rather electroslag welding. Thank you.